Equations and expressions plus. These are tough. Let's get right to work. Question 1. Which of the following is the best approximation of 18/51? Okay, so if you see this problem, you're like immediately going to dive in and going to say 18 divided by 51 is something, and then do the math out and say, okay, here's a decimal point, here's a 0, we're going to have 3 and something after that. That'll take you way too long, and it'll use all your computational energy that you're going to burn out over a 3-hour test. So there is an easier way to do this. If you have to do it this way, you can do it this way, but there are easier ways to do these problems. You only have 95 seconds per problem. So if your immediate inclination was to do it this way, maybe I can convince you that another way is better. Okay, so if you're a math nerd, and you should be a math nerd, so you know that 17 over 51 is equal to a third. You know that 51 divided by 17 is equal to 1/3. You just know it. And if we have a 18, which is bigger than 17, we know that the approximation is going to be greater than 0.333, right? Because if it's greater than 17 over, if 18 over 51 is greater than 17 over 51, which is a third, the answer is going to be greater than 0.333. Well, how about A? A is less than 0.333, etc., etc. So that's gone. Anything else gone? Okay, no. We also know that the answer is going to be less than 18 over 50, right? The answer has to be less than 18 over 50. So I should write it like this actually. The answer is going to be less than 18 over 50. And 18 over 50 equals, if this is over 100, that would be 36. So it equals less than 0.36. Why? Because 18 over 50 is 0.36, right? That makes sense? And we know the answer is going to be less than 18 over 50. Less than, because we brought this number down. As we bring this number down, 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 the total value of the expression 18 over whatever is being brought down goes up. As this number goes down, the total value goes up. Think about it. 18 over 1 would be 18, so that would be really big. And 18 over 51 is less than a half. Okay, so this number, as the denominator goes down, the total value goes up. So if we bring that down to 50, we know that we're bringing the value down. So it has to be less than 0.36. It has to be less than 0.36. So anything over 0.36 has got to go. And we have our answer. We're good to go. Okay, if you like question 1, question 2 is similar. Don't get weepy when you look at this because it says best approximation. If it didn't say best approximation, you would be like, oh my gosh, how am I going to get a common denominator out of 81 and 10? That looks like that number is going to be huge. But this says approximation, so right away you should say 41 over 81 is a lot like 40 over 80, right? It's a lot like 1/2. This is a lot like 1/2. If you have 41/81 of something, it's like having a half of it. And that minus 3/10 is easy. It's 5/10 minus 3/10 equals 2/10 equals 1/5. We're good. Question 3, if you've never seen a question like this before, you might get really anxious, but it's not that tough. It's not that weird. Bear with me. This is dot, 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 just means nothing. It's just dot, 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 x equals 2x minus 2. It's a function. It means for whatever value x is, if there's dot, dot, dot before it, it's going to equal 2x minus 2. So let's do what's inside the parentheses first, because, that's generally the order of operations. And we have two kind of terms. And let's figure it out. So dot, 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 5 is going to equal 2 times 5, right? Because dot, 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 x means 2x. So this is 5, so it's going to be 2 times 5 minus 2. That's going to equal 8. Dot, 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 3, well, what does that equal? Well, again, it's 2x minus 2. So that's going to be 2 times 3, because 3 is inside the parentheses, minus 2. That's 6 minus 2 is 4. So now we have dot, dot, dot. This is 8 minus 4. Again, don't get so scared and weirded out that this is a new form that you've never seen before. It's just a function, and you're going to use your standard order of operations knowledge that you learned in 6th grade. Oh, 6th grade, memories. You do what's inside the parentheses first. So 8 minus 4 is, wait, how many fingers do I have? 4. Okay, that was cool. Dot, 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 4. And now we're ready for the final one. Remember, dot, dot, dot equals 2x minus whatever, minus 2. So we have 2 times 4 minus 2. That's 8 minus 2 equals 6. We are good to go. Okay, that last one was fun. This one's even better. X down, arrow down, or x to the down equals 2x minus 1. So it's another function. It's not that scary. It just means whatever x is, you put it 2 to the x minus 1. It's really not that scary. Okay, and we have 2 arrows here, but let's do what's inside the parentheses first. So we have 2 arrow down, and that equals 2. You know, don't get confused. I wrote this question to be confusing because this 2 is kind of confusing with that 2. But the x is what's important. The x is what's raised to the exponent level. And we know that exponent is going to be a 2. Why? Because that's 2 there. Okay, what's 2 to the second? Well, that's 4 minus 1 equals 3. All right, so this guy, 2 to the down equals 3, so we're going to replace that with a 3. Now we have 3 to the down, and that's 2 to the 3, right? Because that 3 goes up there in an exponent, right? Yep, we got that, minus 2. 2 times 2 times 2 is 8, minus 1 is 7. 2 to the third is 8, because that's 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, minus 1 is 7. And we're good. Question 5. A basketball player scored an average of 18 points per game in a 10-game season. Without her worst game, her average would have been 19 points per game. How many points did she score in her worst game? Okay, so we're doing an average question. There's 10 games. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the average of them. So if we take all of these 10 games, we add all of them together, and then we divide by 10, our answer is going to be 18. So what do they all add up to? Well, let's just multiply each side of multiply each side of the equation by 10. That cancels out, and this becomes 180. All of these games, all of these 10 games add up to 180. And we're losing one of the games. So let's pick one game. Oh, sorry, guy, we're going to call you the worst game, and we're going to get rid of you. So if we have 1, 2, 3, 4, 5, 6, 7, 8, 9 games left, and we get the average of that by dividing by 9, we're going to get an average of 19 points per game. 19 points per game. Well, again, if we multiply each side of the equation by 9, we're going to get what all of these 9 games, the best 9 games add up to, and the best 9 games will add up. If we do the math here, 19 times 9, you can do it out long if you need to. It's going to be 171. So all of these 9 games here, which are the same as those games there, add up to 171. So all of these 9 games, because their average was 19, all of these 9 games, these 9 games, all of these 9 games add up to 171. And the worst game is what we want to find, and they all add up to what? 180? That's simple. We can do the math. The answer is going to be 9. We're good to go. Okay, question 6. Evaluate the following. And you have radicals. And you're like, oh my gosh, I don't really work well with radicals. Well, you should get over that because you need to work well with radicals. And you think about it, you're a math nerd. You're going to have to work well with radicals eventually, so why not get good at it now? It will be a good idea. What's the square root of 25? The square root of 25 is 5. If you don't know that, if you don't like it, you should just accept it. 5 times 5 is 25, so the square root of 25 is 5. Now you can do plus and minuses because negative 5 times negative 5 is 25, but let's just leave it as 5 for now. All right, so we got 5 over here and 5 over there, and now we have the square root of 75. That's the tough one. Square root of 75 is the same as the square root of 25 times 3, right? Yes. Square root of 25, we know, is 5. Square root of 3 is just the square root of 3. So here we have 5 times 5 times 5 times the square root of 3. 5 times 5 is 25, times 5 is 125. Square root of 3 just sits there hanging out. It's good, and we're good to go. Okay, next question, question 7. Evaluate the following. Square root of 10 times square root of 10 plus square root of 75 times the square root of 27. Okay, first, square root of 10 times square root of 10 is obviously just 10. You should like this question by now. When you see it, you should be like, oh, that's familiar. I know that. I know how to do that. Other people taking the same test I'm taking will probably get it wrong, but I'm going to get it right. Square root of 10 times square root of 10 is 10. Next one is a little tougher. Okay, first, square root of 75. We know that is 25 times 3, right? Because we just did it last problem. Square root of 25 is 5, and square root of 3 just hangs out there as square root of 3. And remember, this is plus all this multiplied together. This is square root of 75 times square root of 27. If we have 27, square root of 27, that's like square root of 9 times 3, right? So here, that's the square root of 3, square root of 3 times 3, right? Because square root of 9, 3 times 3 equals 9, so square root of 9 is 3. So we have 3 times the square root of 3. Look what we have here. We have 5 times 3 and square root of 3 times square root of 3. And square root of 3 times square root of 3, we should know, we should not be scared, is just 3. Just as square root of 10 times square root of 10 is 10, square root of 3 times square root of 3 is 3. It doesn't matter that they're not next to each other because of the commutative property of multiplication. You can multiply numbers in different orders. 5 times 3 is 15. 15 times 3 is 45. Bring that 10 down here. We have 10 plus 45, and we have our answer. Okay, question number 8. You have solved for x and you have a big mess here and you're like, oh my gosh, how am I going to deal with this big mess, and I don't know what to do, and I can start pulling it apart and working at it, but you should look at this, and I look at this and I'm like, oh, you can cross multiply, right? You could cross multiply here and cross multiply there and you'll be successful. So let's do it. 2 times x plus 2.5 is going to equal 3 times 2x plus 3. Now, this is a good example of, you know how to do cross multiplication while you're solving ratio and proportion problems, but it exists all throughout math. You know, so using one skill you know from one area of math into another area of math and combining them is kind of what this test is all about. It is a helpful thing to do, and we can be successful here. So 2 times x is 2x, 2 times 2.5 is plus 5, and then we have 6x plus 9. Let's subtract 2x from either side. We have 4x, and subtract 9 from either side. 5 minus 9 is negative 4. That shouldn't be scary. Divide each side by 4, and we have x equals negative 1. We're good to go. Okay, question 9 is pretty easy. It just deals with absolute values, which in and of themselves are not too creepy, not too weird, not too scary. So it says x equals negative 1 and y equals 3. So negative 3 times absolute value of negative 1 to the third absolute value minus absolute value 3, swap that out for y, minus 1 absolute value to the third. Okay, so if you have the exponent inside the absolute value, you do it first. If it's outside the absolute value, you do it second. Missed a parentheses there, but we're good to go. So what do we do first? Well, let's do inside here. Negative 1 times negative 1 times negative 1 is negative 1, but then you take the absolute value of negative 1 and you have 1. So you have negative 3 times 1. This is minus 3 minus 1 is 2. 2 cubed is 8. All right, 3 minus 1 is 2. Absolute value of 2 is 2, and then you take the cube of that as 8, but it's minus 8. Negative 3 times 1 is negative 3, minus 8 equals negative 11. Like I said, not too tough. We're good to go. Okay, question 10. I just threw this in there because there's a unique rule when you have inequalities, which you probably should be aware of. So here, how do we solve this? Let's just add 22 to either side. And that cancels out. We get negative 2x is less than, let's add the numbers together, and we have 20. Now we're going to divide by negative 2, right? Because that's the standard thing. If this was an equal sign, it would be easy. If you divide both by negative 2, you'd get x. If it was an equal sign, it would be x equals negative 10. But here's the trick. If this wasn't a negative, we could leave this inequity alone, but because we are dividing by a negative 2, we have to actually flip that around. We have to flip it around. When you divide or multiply by a negative, this sign swings around, and you have negative 10, but you have x is greater than negative 10. Think about it. You can just plug in numbers just to be safe. X is greater than negative 10, so 0 should work for this. So negative 2 times 0 is 0. Minus 22 is negative 22, which is indeed less than negative 2. If we kept this sign the other way, 0 would not be a solution, but 0 is a solution. So that's a way to check to make sure that you correctly flipped it around. Also, if you get just kind of scared about flipping signs around by multiplying by a negative, you could just do the whole thing a different way. And you could say, I don't like having a negative 2x here, so I'm going to add 2x to either side, and then I'm going to add 2 to either side as well. So negative 2 plus 2 cancels out. I just have 2x on this side, and negative 2x plus 2x, that cancels out. And I have negative 22 plus 2, which gets me negative 20, and I have this stays the same because I didn't do any multiplying or dividing by a negative. And then I divide by 2 again, and I have x is greater than negative 10, which is the same thing I have up here. There's a couple different ways of doing it, but you got to make sure if you divide by a negative, then you flip that sign around. But x is going to be greater than negative 10 any which way you choose. X is greater than negative 10. Oh my gosh. So that's a good example. You can't do all the work right and then circle the wrong answer. The answer is there, down here. We're good to go.